System development environment. Linux is a flexible, source-based system for building and managing custom Linux distributions. It allows users to create highly optimized and tailored Linux operating systems for a wide range of hardware, architectures, and applications. Key features of T2SD Linux source-based distribution.
Welcome everyone. Good morning, good evening, good day. Welcome to Fixing the Open Source World, one IBM Red Hat engineering bug at a time. Really currently we are impressed here how broken some things are, including Kexec. For those who are new to this stuff, Kexec is a Linux kernel, 15-year-old Linux kernel facility to in-memory execute a new kernel. Like you're running Linux 693, you want to boot 699, cutting the reboot time and other boot infrastructure stuff like P3. The P3 was always, since Sony added other OS Linux support, actually booting like each P3 boot via Kexec. First the bootloader Linux is running and then you can also Kexec on this. I use this massively. Each update on our servers, Kexec without BIOS, cutting down boot time, and certainly the P3. And since a while that was broken. Of course this is architecture specific, so it needs to have a dedicated implementation for all the architectures. Think PowerPC, RISC-V and x86 and stuff. It doesn't even support all architectures. And for a while I knew it was broken in PowerPC, necessities for superior RISC, high performance living. Case in point here, PowerMac 11.2, but it would also Xserve, previous video. And the crazy stuff, I spent 4 freaking hours debugging this live on our More Live Twitch channel, right? In case you're wondering, where have we been the last months while YouTube videos were running quite okay. We actually do a lot of stuff on Twitch these days, not to disturb the YouTube algorithm gods. So this was broken. We debugged that for took me 4 hours, and I have no idea what the IBM developers were thinking, because I'm sorry to break the news, it's entirely broken. That's the kind of stuff like, how could this, similar to previous video, how not to code, looking at you Intel, your broken CPUs and stuff with Thunderbolt utilities, but you would think a big mega corporation, previously the flagship of American high-performance mainframe and PowerPC engineering, with Apple and Motorola and IBM, right, AIM alliance for PowerPC computing, they would know what they are doing, but no. So what happened? Do I even have? I have this. Actually, I can show you. Can I? I mean, I could reboot. Anyway, it doesn't work. I mean, I should have prepared better. Did the Kexec? Okay, let's simulate that. Dev. I still have the SDC installer script here. Media of install, maybe here. Install verbose media. Let's just build Kexec tools. And then user sbin. Does it work from here? Probably, right? And so this should not work. It didn't work. It's okay. Config Linux. So this is how this would work, right? You Kexec, the kernel, execute my -l Linux kernel, VM Linux here, and then theoretically init but whatever. And so yeah, on many PowerPC machines, that's the bug, right? Could not get memory layout. It's due. Okay. And so now watch my fixed version. Actually, I can even init rd boot. I mean, I can show you, not that you tell me it is that. No, it's not. It's broken. Init rd, so the matching init rd, right? What have I? Aspen maybe. So yeah, couldn't get memory. Okay. So my fixed version as of today may I present to you T2 Linux, the only Linux distribution that can probably Kexec on most PowerPC machines. So there are some warnings, like unexpected instructions, but they are not from me. Like with my fixed version, actually, yeah, we can Kexec that. And so I should have used the basically like, so normally you would reboot and stuff, but I can simply, to better illustrate this, like Kexec E execute, make it so, engage, Kexec E for engage, PCAR, right? As Star Trek Next Generation. And so you don't see that, but from the boot time you will see, I mean, it worked 2 times. Actually, this is a Kexec second time. I never Kexec 2 times. Let's see, does it? 1 Mississippi, 2 Mississippi, does it? Actually, maybe I should have checked if that works twice. Okay, maybe it only works once. It would be a shame. Does it come up or not? Okay, maybe you can only Kexec once. Which also, nothing like rebooting it. So what is the issue? Let me just power cycle the thing, which is unfortunate, but it is what it is. So much you can Kexec once. And so debugging this, the people always think like, yeah, just some small bug, right? So it took me 4 hours live. You can basically watch all of that on Twitch here, if you wanted to, like if you wanted to full raw experience of debugging all this stuff, that would be here. Of all systems, no, not latest UDEV. Did I not change 3 hours 10? I think. Wait, that is strange. I edited the. Okay, whatever. It's like, yeah, 3 hours plus some another hour fixing this stuff. And when my system comes up back again, after, maybe I should, so much to showing you this unedited. And so I will show you what the bug is. And it's unbelievable. Absolutely how this could not get memory loaded. So there is a chance that on some IBM machines it might work. On the P3 it also works. Also, I mean, in general it will not work probably, because like this here is also a bug and I patched this away, right? So even with my modified version, like, so basically as it stands as of today, Kexec does totally not work for me. Not on the P3, not on an IBM Open Power, not on an Apple Power Mac. Because even with my so this could not get memory layout happens most likely on all Apple Power Macintoshes, which is, yes, they are 15 years old, but hey, that is a mass quantity of power machines, PowerPC machines at people of all the friends and family playing along at home, right? Like most people have a G3, G4, G5 Apple Power Macintosh, right? If they don't have a P3. So let's show you the bug. Right, this was tempfs. Okay, let's do a T2 build Kexec, also no clear, no clear source. Okay, Kexec tools. How do I show you this best? Maybe I move, because I have currently 2 patches. This is basically the summary and basically a quick run of 30 minutes of what took 4 hours. And I can't believe that I regularly do, like, this stuff in my opinion should work. Like, this is not complex commodity, the C stands for commodity, right? Like CISC, commodity, inexpensive, yeah, like RAID, right? Commodity, inexpensive Intel CPUs. Like, no, this is enterprise, IBM enterprise gear, and you would think it would work, right? Like if IBM had one job to stay in business, it would be like to have this stuff working. So this is PowerPC mem range stuff. Let's move that here to back up. So this ELF ABI, I just disable this instructions check for now because it also fails. So yeah, let's build that. Like maybe also let's build it verbose to better, and because then it's not patched version. And so I'm basically shocked that this was broken and doesn't work. Especially 15 years after it was invented for P3 and stuff, right? Like this is of all the things that should work, like all Linux P3 users and certainly IBM Enterprise users supposed to use this. By the way, this is not Epic Spectrum, this is live on people. You can't use an Apple G5 anymore. Hey, this is a dual core 2.5 gigahertz, massively out of order, 128-bit data path, high-end RISC system, right? It's like, can't use this 15-year-old stuff. Of course you can still use it. So if we could basically do have here some eval, like basically eval the stuff. It's like, yeah, some warning, right? It's C code, it has some warning. It's probably not my warning, I guess the warning was there already. It's like, yeah, so couldn't get memory layout, right? This is in Kexec PowerPC, get memory layout. And so, of course, in this 4 hours, why did it take 4 hours? I had to read all this code, right? Like Google remediate, what are they doing here? Not to mention here that I'm not the most impressed by this open coded nature. Yes, this is how C code looks, right? Like fiddle some string here, because here's some open firmware, like proc, open firmware stuff, right? Like string copy file name, like string cat some more file name, and open, read a little bit and stuff, right? Basically, I would say every language would be better suited than C to parse some proc files, but hey. So after debugging, basically this took me probably nearly 3 hours to debug all the stuff, like what's going on, memory ranges. So that is where they determine the memory layout, right? You would think, like, of all the complex mechanisms of machinery, it's finding memory, putting the kernel there, and all the infrastructure of, obviously not the easiest endeavor to execute a new kernel while your Linux kernel was already running, right? So it turns out that, do I have this here somewhere? So the main thing here, what you will find, they open here somewhere, like all the stuff I don't have, right? IBM dynamic reconfiguration memory and whatnot, I don't have this, because it's an Apple Power Macintosh or P3. And so memory add, right? Yeah, memory add, there's one there, it's like memory, PCI and stuff, right? Where was the first here? And here they get the start and end of the physical memory. Like all they need to know is the physical memory addresses, which usually is 0. Like let's say your 4 gigabyte is like 0 to 4 gigabyte, right? Might be more complicated with holes, with PCI devices, with different size DIMMs, with hardware chipset specific offsets of holes. There might be holes, right? Non-continuous of a gigabyte here, a gigabyte there. It's like, and so this code, like this is a bug. And this is completely buggy. I have no idea what the IBM engineers were thinking. They should have an open firmware specification, but it needs this YouTuber on his vegan time to like, this could have never worked. Like maybe it works on some IBM P-series machines that I don't have, and maybe then also only partially, because what they do here is they open the proc device tree, where the Linux kernel exports the open firmware device tree, and they open here the file in memory add, some number and stuff, and rec here, this rec file here, and then read the first two 64-bit numbers. They read here, basically they read here max bytes, which might be 128, but then they only read this here, right? Like they cast this buffer to 64-bit integer here and big endian 64 to CPU start and end. That's it, right? And turns out it's a bit of a pity because that's 0 on my Apple, and probably it is 0 on nearly all Apple Power Macintoshes. And even if that would be buggy, so this code only works on maybe some, which I have none, but maybe there are some IBM machines where the first memory of multiple ranges happens to be a useful memory range. And only then it's probably buggy because most likely, as all my other PowerPC machines have multiple entries, right? I don't have a single PowerPC, and I have an IBM RISC System 6000 there, and Power 8 obviously, as we are professionals. If that works on some IBM PowerPC machines that I don't have, then only partially with just lucky that amount of memory, like only be able to load the kernel memory in that specific randomly first memory range. I show you, right? So this is a file hex dump Also, you basically want, I slightly did this wrong, oops. I should run this in tmux so that you see that better. Hex dump c proc device tree memory at 0, 0 rec. So, and as you see, they read this 0 and that 0, and respectively can't get the memory layout. I mean, I did not write all this code, so it took me like 3 hours to find, but I was like, dude, what were they thinking? Like, how did they test this? I mean, on the P3 it works. I mean, theoretically it works. Again, on the P3. Also, why do I debug this? Because I currently can't reboot my P3 since a year. I can't for a year reboot my P3 because Kexec doesn't work anymore. So, and even if it currently it also doesn't work on the P3 because it can't relocate these unexpected instructions here, which is probably also another bug. So there are 2 bugs, and you would think this is why I'm getting increasingly crazy, driving me crazy, because this kind of enterprise stuff, that's not a commodity home feature. Like this Kexec is only used in data centers, embedded systems, or the P3, right, or other developers. You would think this enterprise features for IBM PowerPC are rock solid, but as seen here, was it this file? As seen is this here. Even the memory ranges are not implemented properly. So I don't know why Apple has chosen. I mean, yeah, it doesn't make the most sense. But again, so because like this DIMM slot probably it's 4 interleaved. So it has 8. It has 4 pairs of DIMM sockets, and they are in pairs interleaved, like even on modern Ryzen and Intel, for example, just that is DDR2 and that is DDR4 and 5. So, and that is probably, I guess, the pairs of memory banks, I guess. And so as you see, so this here is the first, like why Apple does start this from the end, I don't know. It is what it is, right? And you could say, yeah, Apple did some non-standard shit. That's like, yeah, maybe, but it's an IBM open firmware standard, right? Like if you boot an old, I don't know, current, I don't have too many current, but if you boot an old IBM RISC System 6000 model 43P or RS6000P50, previous videos, then you have something, as you will see that the open firmware is copyright Apple and IBM, right? So it's not like Apple did some nonsense. Like, no, they shared the open firmware implementation in the AIM alliance of Apple, IBM, and Motorola. So yeah, so this code takes just the first entries, not all the others. So it's basically even on high-end IBM systems, it's just using the last or first whatever open firmware implementation puts their things. Absolutely shocking, right? And I don't know why it always takes like everything non-standard that's not used by, I don't know, mainstream. I mean, it's broken. Like, why is everything I touch, like you boot something, broken. You plug previous video. You plug in latest and greatest high-end Intel Thunderbolt, previous Twitch live streams. I even had to fix Thunderbolt. Like, why is everything? You plug in the latest and greatest, doesn't work. But there's more. They have a second. After I fixed this, it still didn't work. So how did I fix this? I rewrote this function. Of course, took me 45 minutes to rewrite this function to actually pass all the entries, like rocket science. Actually, don't use the first, use all entries that are non-zero. And they have this more. Like they have this, even after I fixed this, it didn't work. And then it errored out differently because turned out they also have here, they determine the memory, they determine this twice. Like, also not amazingly written, like because somehow here RMA base. So here's in get dev tree details. They do this again for reasons that are unclear to me. Like I would scan this once and have the base. So basically they want the beginning, the lowest base and the highest ever possible address. I mean, I would scan this once and be done with it. But they have this exactly identical broken code here twice. So how and why this is possible, like to get it twice wrong, right? Because here the code deleted the whole entries that were then, after I fixed this, all my preciously generated address ranges were deleted, because this code here again does the same thing. Opens here, memory at memory rec here, reads the same file again, but then only uses again the first two values, the first two here. The first is base. So basically, even this is buggy. It's the same buggy in two. I mean, I would only again implement it once. Like, why they do not generate the min-max of the address range in one pass? C code, another level. It's difficult. You need to study. You need to go to the Linux kernel foundation C university and learn some Linux kernel C or whatnot. Yeah. Obviously, I rewrote this also. I can show you the fixed code because currently, again, the first entry is 0 on probably all PowerMacs, especially probably if they don't. Maybe if you populate all memory slots, which I have not. I don't have a single Mac except the G4Q probably that doesn't have all, like, who populates all memory slots, right? And then it would take the last, like it would only work on the last highest addresses, then most likely on Apple. Yeah, obviously you can't just use the first two entries. You need to iterate all of them and compare min-max and determine the actual base and last, which may or may not be the first or last entry. So obviously you do it proper, which means iterating them all and comparing them all. What's going on here with, I believe this here is a new, because since it's also the only constant is change and regressions, right? The Linux kernel changed for slightly higher, like maybe 1% higher performance, 1%, right? Not 1, not 2, not 3, not 5, no 1, maybe plus minus, give or take 1% higher performance for a slightly more modern and slightly more efficient calling convention called ELF ABI, Application Binary Interface version 2, because version 1 sucked. IBM. What should I say? And so the Linux kernel recently, a year or two ago, switched by default or by option to ELF ABI version 2. So I believe those here, as far as I've seen, this unexpected instruction things, which are also 0, I believe that is a different bug. So I just disabled that to, instead of dying, to just continue. It's like, yeah, probably will be fine. Actually, so it worked on my G5. So that is like, yes, only constant change in regressions. You change some ELF ABI calling convention relocation stuff. It's like stuff breaks, and somehow we are apparently the only ones who care about reduced instruction set computing and power efficient PowerPC stuff. To show you also, like, I think the terminal here, if this is native, let's see if that fixes here my mouse cursor stuff. Kexec. So to show you how I work around that, for now, of course, I have to send this upstream sooner or later. Maybe later, maybe sooner. I believe I have in the meantime, like, yeah, I need 2 ELF. I mean, I should probably rewrite this. Like, why does T2 Linux have so many hotfix patches? Because stuff doesn't work out of the box, right? You build some stuff, doesn't work. So yeah, there are some hotfixes. So was it this one or the other? Yeah, so this one here is die. And I am like, yeah, printf is enough. I don't need to die. Also, I logged this instruction because I wanted to see the instructions, so somewhat 0. Maybe it's simply trying to relocate the wrong section or whatever is going on. I need to spend another 4 hours to... I mean, it works with this error converted to warning by this rocket science scientist here live on YouTube. But I need to further go remediate. I mean, obviously, I can't send this upstream. I need to fully understand. Probably it's trying to apply relocations, which are relocating the address space of an ELF object, executable object, to another address space. It's linked to some address or dynamically relocatable. So relocating all these jumps and calls and stuff and var addresses to whatever location memory that is allocated to. So the other thing is mem ranges, all right? So that is the actual fix, so that is quite some, it's like, yeah, I had to rewrite this. Because it's entirely broken, right? So we need, so like I made this here, I needed this assigned because some of these Apple entries are invalid, so I wanted to check the negativity of these two complement things. I needed a new I here, and then I removed here this, it's like, yeah, also coloring, right? Like, no, why do I not use syntax highlighting? Syntax, was it off? It's like, hey, I can actually read this, right? Like, who likes colored background, like ratio? Minus, minus, plus, plus, right? So I'm changing both locations of like, hey, let's use the first two entries, which are 0 in most PowerPC machines I have, to actually like, yeah, 4i in n divided by 8 of actually buffer I plus plus thing of mask here some bits away and check negativity and actually add multiple regions that might be there. And the same here, of actually need a start and end thing here, and then here instead of just using the first, feeling lucky, like IBM's way, feeling lucky, probably fingers crossed, Red Hat engineering, to actually RMA top 0, the other was -1. So again, for all entries, rocket science, iterating memory ranges, difficult. Start and end, again, some signage validity checking, S-pair on my PowerMix, on all PowerMix I have, and whatever, I don't know, I don't have the, if IBM Apple is watching, if someone has a full PowerPC open firmware specification, PDFs in my inbox, welcome to know. I mean, it looks to me like first bit set not valid, whatnot, whatever, something. It is what it is. Works for me, just like negative stuff is probably invalid, and the first bits are some special encoding sometimes, so let's not use them, and that actually works. Like if start is below all bits set RMA base, then that's the new base. If end is greater than RMA top, which starts at 0, then set this, and voila, it actually works. Kexec, let's try that again, right? Nothing like, do we also have -- init rd? No. Kexec as a final presentation, init rd. Also, by the way, I run T2 Linux, latest edition, right, 24.6. Everything latest and greatest. Yes, everything latest and greatest. Just say Linux kernel 699. It probably has this for that booting the latest Linux kernel. Actually, nice. Kexec works, right? Kexec, new Linux kernel, right? So kexec -l -init rd, boot init rd, and kexec. Usually I synced, but it doesn't matter. Exec. So usually in T2 shutdown should be enough, but that would be partially misleading. Let's see, did I do that correctly? It did work before. Okay, my cursor is not blinking. Probably I kexec a couple of times today, but never twice without. Let's see, 1 Mississippi, 2 Mississippi. Did I hit any typo? I mean, maybe sometimes I'm unlucky. I don't know. It probably depends how your graphic card unit stuff works. Presentation, marginalities. And yeah, there is that. Shall I subscribe for this crazy dude who fixes all the Red Hat and IBM bugs? I guess you got the idea. And also keeping all this stuff for P3, right, around. Why do I do this? Because I need this stuff working for P3, and obviously to improve debugging. And that's so okay. It's not the second time. Apparently, sometimes the thing doesn't come up for whatever reason. It worked earlier in my testing, but of course not live on YouTube. So next I need to pack out the P3 reports are that also something upstream broke P3 again. So probably guess who needs to spend another 4 hours this weekend to debug through the P3 support like we do every quarter. But that is for another day and video. Let's see. One last thing here. You can, by the way, go there and check upstream, right? If you want to, I'm not making this stuff up. I wish I would. But that is also why we can't have nice things, right? Like for me, it's absolutely not understandable how this code can be so buggy. You would really think someone with a specification and people at IBM would know what they are doing. But I am probably as shocked as you are. If you are, shall I subscribe? Leave in the comments below. Questions there, are we good? Yes, thanks. We fix a couple of bugs a day, so we are completely happy and enjoy life. Greetings to Brazil, greetings from Bavaria, that's amazing. Greetings too, by the way, do we already, it's booting already. Greetings there to the world. Can video cut it to count? Yeah, I fixed this already. To my friends and relatives, thank you for creating a hobby. I'm seeing and fixing a kernel, clearing my mind. Fun, happy you enjoyed. Honest question, how do you get from K and R to this? What precisely do you mean with this? A wise man admires simplicity. I really hope you're doing well. Yes, we're doing well. We are basically, if you're wondering why we didn't have that much on the YouTube channel, basically the YouTube algorithm did run some videos quite well, and that is why we primarily live streamed on. Okay, let's do this first because then you see this in full, right? We were extremely busy, right? As you can see from our GitHub history, which we actually checked here. So. Basically busy, 3,406 contributions in the last year here on this increasingly. Also T2 use is over 8,000% up. I wonder if that is related to my daily public relation YouTube live development in Twitch. And GitHub is there of our increasingly amazing Linux distribution, where even SGIO2 works now. Oops, also sorry. And we obviously live stream from that, right? If you're wondering, yes, this is so efficient and stuff that we live stream from 698 T2 on AMD custom APU 0405 Jupiter 1 aka Steam Deck. Necessities for high performance Linux desktop living. Doing well, software developer, listening to your runs is very therapeutic. Happy to hear that. Thank you for efforts. Keeping. I mean, it's not even legacy stuff, right? I have a Power 8, right? Power 8 also nearly 10 years. But hey, it's 80 thread. I have an 80 thread IBM Power 8. And that's not like 80 thread, like sure, it's 10 cores. Yeah, it's 8-way SMT, so 10 core, hey, but 80 thread and stuff, right? So that's not that legacy, and theoretically this Kexec applies to like obviously I would be surprised if latest, I mean maybe they don't, I don't know if latest and greatest Power 10 have like, donations welcome, especially to my Patreon, to keep all the stream alive. I would be surprised if Power 10 stuff doesn't have more than one memory region, right? So it's not like, I mean, the code is obviously incorrect. It only works if the first entry happens to be somewhat valid. If not, then it doesn't work, which is on all my systems. So yeah, Dash going upstream. I mean, I've just fixed it today, and I also need like, yeah, eventually going upstream. Of course, theoretically, the more you shall subscribe, maybe the more you donate, the more I can afford. Like, hey, I work 80-hour weeks. It's like I probably need an assistant just for upstreaming, but which I literally fix so much I have no time for upstreaming. Like each time I try to upstream, it's a catastrophe of like the GCC patch is still not upstream 4 years. Remember, actually fixed GCC for Power 4 and G5 and Cell, right? It's like, but hey, we're making progress. We're discussing with GCC developers. They will apply this one-liner 4 years later soon, I believe. Just this morning I got a new message of like, hey, do we want to apply it like this? Yay, 4 years, took only four years to get the one-liner fixed in GCC. Greetings to Kiel, Bavaria, all the world, from A to A, from A to Z, from, what is it, Zulu, from the Americas to Australia, Taiwan and Zulu. Kiel in Bavaria, Hamburg and Jesus Christ. Did anyone validate this? Well, I guess it booted on some systems for someone, and that's probably was fine. No, there's a hype. I mean, it's, yeah, bugs can happen to anyone. It's just like, I don't quite get how such bugs always can, like, I mean, not to mention, did I mention Thunderbolt also didn't work for me? Shall I subscribe? Thunderbolt and other review videos coming soon. IBM should hire you. Yeah, I think the Linux Foundation and stuff like would be really cool. Like some 100,000 euro donations from the Linux Foundation or IBM would actually keep quite some flow of relaxed debugging patches. But it's not like the Linux Foundation would have a program to donate to regularly fixing developers. Unlike, surprise, T2 Linux. Did you know that T2 Linux, unlike IBM, Red Hat, most other companies, also Linux Foundation, has actually a feature bounty program, and nearly, while they are security bounty programs, feature bounties are very rare, right? So we don't pay for security vulnerabilities because they are usually, as you see, security vulnerabilities look no further than probably such IBM code, right? You get the idea. Package Kexec tools of, did I move this to backup, right? Like stuff that could potentially be security. I mean, not that that would be the most, but like, hey, they use zero memory and stuff. But we have feature and bug bounty, I mean, a little bit bug. Like, did you know that you can actually earn money with this high-end Linux distributions because bugs marked by me with labels? Yes, not that the biggest. We are working on getting rich to pay you more, but hey, bounties up to 120 freaking euro. Where is Debian, Intel's Clear Linux, or Oracle's Broken, or Red Hat's Redneck Engineering? Ah, it's no IBM. IBM's Redneck Engineering Linux paying you bounties for like, hey, I want to maybe implement some Android L4 microkernel or BSD support and get 120. Yeah, it's like, it's bigger things, but hey, the more you Shellac subscribe, the more successful you spread the word, the more 100,000 users. Hey, our growth is only 8,000%, so there certainly is still some room for improvements. The more T2 growth, the more we will even give back more than the Mozilla and Linux Foundations ever have. So that's basically it for today. I hope you enjoyed to learn something, especially like if you want to Kexec. We also improved some other things, right? Like SVN log here. Then it's like, yeah, we were busy like daily updating, improving stuff as seen here by this nice activity chart of things are happening, wild things, risk things, and reduced complexity things. People have questions about the T2 use, but recommending some of my students to give it a try. That's amazing. Happy to hear that. Please contribute to Patreon, guys. Just a few. Yeah, just $1. As imagine 1,000 people of 30,000 subscribers would donate $1 a day. That would already be 1,000 freaking euros that I can spend significant amount of time to actually not do this after work on the weekend, but imagine how much I could fix if I would work all day and wouldn't need to like run my company to keep the bills. By the way, video and work sponsored by Exacode, my amazing solutions that just work. Who would have thought every day? Mostly paperless office stuff, primarily for macOS because that pays the most, and Windows makes me depressive. And of course embedded Linux and other virtualization and stuff, amazing technologies. If not, you run T2 Linux. That's it for this video. Amazing that so many people tuned in. Greetings to the world again. Of course, C has upstream PTSD. Yeah, I have upstream PTSD. But hey, I sent not only I upstreamed. Hey, I get better at upstream. The more you shall subscribe, the more YouTube pays, the better I get with upstreaming. And I said this again. Also, what do you expect from me? I send P3 unbreaking to upstream Linux kernel. Like, yeah, we want to have it's like different. GCC Bacillor, ping, 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 mailing list, Twitter, mailing list, 4 years later. Oh, now we could slowly start to... I didn't even get a reply for 3 years, right? It's not like 3 years ago they told me clean this up. It's like it was one line anyway. Like clean up this one line. Like no, previous video, after 3 years of pinging and pinging and pinging the GCC Free Software Foundation people, after 3 years they told me, oh, by the way, do you also want to write a test case for that? It's like, yeah, okay, thank you. You're welcome. And I upstreamed de-obsoleting, I upstreamed, not yet applied, de-obsoleting Itanium, right? So theoretically on the verge, so share, like, subscribe, potential future Itanium GCC maintainer. Actually, I should. They also like, that's a nice Itanium on de-obsoleting and modernizing some stuff. Can you change some characters in the patch because, yeah, totally amazing upstreaming experience. But anyway, we're getting better. I only work 80 hours a week, so between now and Christmas, it will probably be fine. Did I probably, as we have some, last but not least, I should download this and save this. Basically, this should basically the end. Do we have like here, right? You know,
a lot of people want to send blankets or water. Just send your cash. One of the things that President...
Yeah, just don't send water and blankets and stuff. All we need is cash. We have water and blankets already. Thank you. We have running tap water. Amazing that so many people are here. Nice to be back on YouTube. Share, like, and subscribe. I hope you enjoyed this, learned something. I have some stuff to commit, some more. I mean, it's not yet final, right? It's like there are still some unexpected instruction, relocation things that I need to guru meditate about. So if you want to see more stuff, totally free over on Twitch more often, right? There are also some 2,000 something people there. And otherwise, don't delay, try superior just working necessities for reduced instruction set Linux Living. That is the T2 system development environment. Clean up P3 storage, move offset and break the entire thing plus verified by 3 people. Yes, exactly. And share, like, and subscribe, then I can tell Linux kernel like, hey, that liked by 2,000 people live on YouTube. How do you learn new things, or how do you? I just usually do. I mean, I learn by fixing the open source world every day, including Firefox, Rust, WebAssembly. Hey, by the way, T2 is the only Linux distribution where Firefox with web GPU works on 32-bit CPUs, right? But then upstream, of course, I had to learn Rust and patch web GPU Rust code for 32-bit atomics for like tiny SB 32-bit SBCs. Yes, I should also send this upstream. Not that someone would care about 32-bit Firefox, but yeah. I learn by just doing. Sometimes I buy a book. And I hope to see you next time. Have a good day or night. I have to go home, get some sleep. Guru meditate in my dream about the next bugs, and catch you next time. Oh, by the way, we could run all the outro. Actually, if you have an auto here. And by the way, we now have music. AI generated music.
T2 SDE, System Development Environment. Linux is a flexible, source-based system for building and managing custom Linux distributions. It allows users to create highly optimized and tailored Linux operating systems through a wide range of hardware architectures and applications. Key features of T2 SDE Linux source-based distribution. Customization and optimization. By compiling software from source, users can optimize their systems with specific hardware configurations, ensuring better performance and efficiency. Control over software versions. Users have the flexibility to choose specific versions of software packages, allowing for the inclusion of the latest features or security patches. Cross-compiling support. Note: T2 SDE supports building software for various architectures, such as ARM, Dirty ARM, Dirty ARM, Dirty ARM, Dirty ARM, Dirty ARM. The Linux versatile for different hardware platforms. Embedded systems. This capability is crucial for developing software for embedded systems, which often require customized and lightweight operating systems. Modular design. Modular build system T2SDU uses a modular build system that allows for easy addition or removal of components. This enables users to create lightweight systems with only the necessary software or more comprehensive systems with additional features. Custom package selection. Users can select the specific packages they need, creating a tailored Linux distribution suited to their requirements. Automated build process. And unit testing automates the process of fetching source code, applying patches, configuring, compiling, and packaging software, reducing the complexity of setting up a Linux system from scratch. Incremental builds. Support for incremental builds ensures that only modified components are recompiled, saving time and resources. Continuous integration and testing. CI pipelines. Integration with continuous integration pipelines automates the build and test processes, facilitating regular updates and improvements. Unit testing frameworks. Comprehensive unit testing ensures the functionality and stability of software components across different environments and architectures. Binary package streams.